This is Mrigendranath Ray from Mumbai, India. I would like to present synopsis of my paper in this PPT presentation. The topic is actually on analytical method to check distortion of the seawater dike under wave slamming pressure on the upstream side. Now I will come to the second slide. You can see the Sundarban delta area, which is actually concept of this paper. The distortion of the seawater dike is for the coastal creek land Sundarban alongside Bay of Bengal in West Bengal, India. Sundarban and UNESCO Heritage world largest mangrove forest land is about 100 km from Kolkata in eastern India. I'll go to the third slide. You can see that in the map there is an index map of West Bengal, south of Bengal, and that is showing the drainage area of the Sundarban. By looking at this index map of Sundarban, it is understandable that Sundarban creeks encircles many islands numbering over 50, through which the sea water flows up and down as a part of daily tidal cycle 2 times a day. Since these islands were infested with millions of human population outside the core area of forest, they are susceptible to high wave impact due to bad weather cyclone of extreme level like Ayla, which happened in 2009, and super cyclone Amphan, which happened in 2019. Besides, smaller cyclones 3 to 5 in every year getting generated in the Bay of Bengal area. Total length of the creek along the sea water channels being more than several hundred kilometers, which necessitated designing a fail-safe breakwater section using local soil from site and mixing with coarse sand and a bonding agent like fly ash. The present sea wall is a low height embankment with 1:2 slope made of local soil with both side slope and top armored with small size cement concrete blocks. This protection is sufficient for stopping daily tidal ingress to the downstream side. But wave slamming due to cyclones quite often breaches these existing sea walls. Now I will go to the fourth slide. In this fourth slide I have mentioned important aspect of my paper. The paper has got some 4 points. To estimate the wave slamming pressure for 2-meter high wave on the embankment slope of the proposed section using Farbutter 1986 and Sparboom formula and modification suggested by Stanjak. So in this first aspect, we are estimating the wave slamming pressure, and the wave height considered was 2 meter. Next point is important, that is to demonstrate how to develop a high performance engineered soil mix at site by trial and error method by testing 3 samples of high performance engineered soil mix in a triaxial test setup and deriving the failure shear surface that will produce maximum shear strength of the core soil using Moore-Coulomb equation. Thirdly, they developed a mathematical model of the seawater dike in ANSYS workbench of a proposed section with concrete armor slab 1.5 meter wide, 2 meter long and 0.8 meter thick to be placed along embankment slope, which is I am considering as 1:1.25. Steep slope, but that will satisfy. The core soil trapezoid enclosed within 2 ohms of concrete embankment armor and the bottom resting on over 25 meter by 10 meter by 2.5 meter RCC foundation slab. The armor PCC slab can be strengthened with rebar if found required for the mechanized placement using crane. Fourthly, I established also by calculation stability requirement based on this shape, friction factor, slope of the breakwater, and weight of the armor using three different approaches, that is Ramon Iribarren, Cavanlese, B is Hudson, and C is Vandermeer, and finalized a armor slab weighing 6 metric ton which satisfy the minimum weight of armor stone weight 5.6 ton for design wave slamming pressure. In addition, foundation stability against dead weight was also established by calculation. Next slide is actually the picture of the proposed dike. You can see that 3D view of the proposed seawater dike. You can see also the maximum shear stress value of the core soil. Core soil is actually within these two arms. In between soil is the core soil. So this section is actually maximum shear stress value in the core soil probed at mid section. The total length is 10 meter, and I have taken a section at the middle portion of the 10 meter long dike and probed that maximum shear stress value which we have got in the ANSYS calculation, ANSYS workbench results. So those shear stress value, actual shear stress value, we have compared with against the shear strength of the high energy, high performance engineered soil. So that is there given in the paper in a detail. So with that I close that presentation, and I will wish that you give your comments, and then that I can accommodate if it is any correction is necessary. Thank you for your attention, please. Thank you. I will close the